Hello and welcome to the presentation for the sensor selection. My ETP topic is communication signal that reliable in tunnel, and I will share about the prototype we have made. Alright, so right now I'm showing the presentation day that I have. So we are using the Raspberry Pi as the system, control system, to distribute each antenna inside the tunnel. And we are using Arduino. It's not showing inside here. It's for our communications to present to the ETP examiner. But at first we are trying to use the walkie-talkie itself, but it's because of this module, this small module we are using, it's not able to function with the analog signal. So we just decide to use Arduino as a digital signal to generate and distribute inside the tunnel, and we show the result in this display. Next, my background is about communication system between the operations control center and the transit officer in underground tunnel. Our problem statement in ETP is about signal quality issue due to difference between the antenna and receiver device, and also the signal degrade over long distance in interrupt the communications in the tunnel. So next, here are a few sensors that I picked. As we go through, I have highlighted or darkened this list, which I picked this as my sensor. And I not include this sensor in the previous PDF file, so I'm just include this in here. And we can see and compare. We have found out that our walkie-talkie and the digital frequency is around 433 megahertz, which showing right here, the CC1101. At first I'm trying do this to show the digital and the analog, but after that we found out this is better. And we also use in our ETP to show that yes, our prototype is working as well. So for the frequency range, we are focusing on megahertz. So yeah, this is able to give us the megahertz within the range. And also the size is quite small, which compared to others. Of course, this is smaller. It's the module that we use in our prototype, and it have a more detection and spectrum analyzer by using the software to run to have the signal. So our key variables is the signal strength at the receive point or the receive device, and what we want to justify is the reliable communications system. It's a consistent, the signal quality is not losses. Next, here are some data sheets. It's all linked, so if madam wants to find, you can just click on each one to get this data sheet. Alright, so these are a few products that we can see the packaging and what it's look like. And of course I'm using this Stl-Sdr, but I'm using the clone one because the original one is more expensive than the clone one. Of course the clone one we have to do some research. It's more or less it's the same thing, but it's not sell or sold in the official website. Is like the other copy of this USB toggle. So next we have the reason why I'm pick this sensor. First is because of course that I mentioned the range to capture the spectrums for the walkie-talkie, and of course the Arduino itself, and also the advanced signal analyzer, which offers that there's a wideband IQ data reception, which means that it's able to decode, or say the technique used being to transmit is able to receive by this Stl-Sdr USB. And also it have the others like the integrated, which I just connected to the 5V or to a USB, and the cost of course is more lower than the others, is more affordable. And the key advantage is that this small Stl-Sdr USB, it's made to my my measurements, and it is a plug and play. It's more easily to use, and even in other laptop or computer, you just need you to download the software, and the software is free. And you also can use other like open source software, of course. Next, we will see my experimental plan, because of this should be used in a big scale, otherwise we cannot see any signal strength that, yeah. So the plan is we will deploy SDR Stl-V3 because it's using laptop, so you can connect to each laptop or smaller device like smaller laptop, and it's easy to use. Just install install it in where we want or which point we want in this tunnel, anywhere, and we capture the wideband which IQ data, which means that it's a big wide signal frequencies that able to be received. Later in demonstrate will be more clearer. And our expected outcome is that, yeah, we can see the signal in this sensor. Next, we will proceed to the demonstrate. Right now I will be showing the walkie-talkie. When I press, it's have a red color right here, and if I try to talk something, there's something changes inside here. You can see right this small box. Testing 1 2 3. Testing 1 2 3. It shows that it's sent and received by this thing, the SDR USB, and we can see this dBm right here that's showing the signal strength. If I do it again, testing 1 2 3, 1 2 3, it's around 50.4 or 51 point something. Yes, so this small device is a USB that connects to my laptop and is able to receive from this, yeah, walkie-talkie. Of course, it can find other, like now it's channel 16. Maybe I change to 15. And yeah, I did some for searching to get the 15 channel. So we have another range for the 15 is 460. The range that it receive. All right. So again, so I do this click, and you can see that there's something inside the laptop, and it shows it's around negative 46.7 something. Yeah. So again, I will talk something, so it will change about not higher, but it's a little bit. All right. So you can see this. There is a pulse right here. Yeah. So if you want just some, you have to change to get this. So when we are talking something, there's a yellow here, right here. This will indicate that our sound. If we just take right here, there's not including our sound transmit inside this frequency. So yeah, that's it. It's quite easy. Alright, I wish that's all what I have used this thing, which is connected to my laptop, and my laptop can able to show. Now in here we are showing that using the Arduino, which sending the data and received by this USB toggle. And we can see when we start it start to receive the signal. Now the pulse is being sent or is being received by this SDR, and you can see the pulse is continuously sent and received by this USB toggle, and inside is just a digital data, so there's no sound, and it's more easier for us to show that the Raspberry Pi with the prototype is working. And thank you. This is the end of the presentation.